In this video, I'm going to review the Hisense NU9700 Full Array Local Dimming LED LCD, which is the company's flagship TV for the UK market at least for 2017. Hello everyone, my name is Vincent Teo. I'm a TV reviewer and professional calibrator. I've just returned from a business trip to China, and it just so happens that the first TV that I review once I get back is this television from a Chinese brand. So this is the Hisense NU9700, the company's flagship television for 2017, at least in the UK market. It only comes in one screen size of 70 inches, so the full model number in the UK at least is the H70NU9700. It has some really quite good technology on paper. It has quantum dot colors, which is meant to deliver a purer color spectrum and a wider color gamut. It also has a direct lit LED backlight with full array local dimming technology. So full array local dimming means that there are different zones that can be dimmed and switched on independently of each other to give a higher contrast, especially for HDR. And it is also certified as Ultra HD Premium by the UHD Alliance or UHDA. So in terms of peak brightness, it will reach at least 1000 nits, and its DCI-P3 coverage should at least reach 90%. And there are other factors as well. It will have a UHD resolution of 3840 times 2160. It can accept 10-bit video input signal and so on and so forth to attain the UHD Premium certification. Now let's go into the design. Because it is a full array local dimming LED LCD with a direct lit backlight, the bezel, even though it is quite classy in terms of the brushed metallic finish, is actually thicker than most of the H-lit LED LCD, let alone OLED, that you see on the market today. And the chassis itself is quite deep as well. And this TV is quite heavy because of this direct lit LED backlight. Now, we normally don't count it as a negative against any television, because if the picture quality is good because of the direct lit LED backlight with full array local dimming technology, then we are happy. We don't really care about how thick the bezel is and how deep the chassis is. The panel itself sits on a fixed stand which is fairly wide, so the feet of the stand actually is situated at both ends of the display. So you will need a fairly wide AV rack on which to place the television. So let's talk about picture quality, which is what I and hopefully many of my subscribers are interested about. The first thing first, so it uses a sharp LCD panel which gives deep blacks, but obviously the colors and contrast will degrade when viewed from the sides. But what is more interesting is that, as we have actually seen from previous sharp panel, there's always a slight serrated look to fine line when you actually look at the pixels up close. I'll show you the subpixel structure here, but what happens is that when you actually look at fine lines, fine straight lines, on a true RGB panel, this is also a true RGB panel, but because of the subpixel structure, you can see that there's slight jagged edges that actually protrudes up the subpixels. On fine lines, you can actually see some serration that may be quite offensive to, let's say, if you're a PC user that sits quite close to this television, then you may see more jaggedness than what you would normally see from an LED LCD that uses a really squarish traditional RGB subpixel, such as the Samsung televisions. Now, this is not a problem if you actually sit from far away, but up close, not only you can see some serration in the straight lines, but also because of the sharp subpixel structure, you can also see almost like a dirty screen effect that you normally see on really old projectors. So let's say if you display a wide screen and you stand fairly close to watch the screen, there will be very, very fine dirty screen effect that you can actually see in brighter areas, which can be quite off-putting for some people, especially if you intend to use this television as a PC monitor, if you intend to sit closer. So that is from the LCD panel side of things. The black level once we calibrated it, and I'll get to the calibration later. The measured black level, once we calibrated the peak white to around 120 nits, is around 0.04 nits or 0.04 CDM square, which is probably what we expect from a good LCD panel. So that is the panel itself. Now, I mentioned before that this TV also has full array local dimming. And full array local dimming is considered to be the pinnacle of LED LCD technology because it allows different zones to be switched on and off independently of each other. So in theory, you can have bright and darkness coexisting on the same screen without the blacks being washed out by the brighter element. So when we receive a TV with a full array local dimming technology, we always do a zone count, and we ran our custom authored test pattern with a small white box crawling horizontally and then vertically against the edges of a black background on the Hisense NU9700, and we found that there are 8 vertical columns and 16 horizontal rows, giving us a total of 128 separately dimmable zones. This is not the highest, but it's not the lowest either, and with good backlight management, generally this should be sufficient to give a palpable increase in contrast performance. The main issue with full array local dimming is that if you don't have enough zones and you don't have good backlight management, then haloing can ensue where, let's say, the zones are bigger than the bright object on screen, then the whole zone needs to light up, so there will be light leakage around the zone, what I term as circumferential haloing or blooming. So this TV cannot avoid it, obviously, because 128 is not the highest number of zone, and the backlight management of the Hisense NU9700 is not as good as, let's say, the Samsungs and the Sonys. So from that point of view, there will be some haloing, especially if you actually watch off-axis. But with some appropriate use of bias lighting, by bias lighting I mean some ambient light that is D65 behind the television, then the haloing artifact can be minimized, the haloing effect can be minimized for viewers. So that is the full array local dimming in terms of the zone count. My main concern about this TV are the colors. So out of the box, the colors, they don't look natural. Even in the most accurate, let's say, night cinema and day cinema mode, they don't look natural. And normally on most televisions, there is sufficient calibration controls for me or any other competent calibrators to go in and try and adjust the colors and grayscale to the industry standard to make the colors more accurate, to make the pictures look more realistic. But on this TV, I faced a few problems, and I'm going to run through them. The first thing is this. This TV has some sort of, I don't want to say that it is ABL or automatic brightness limiter, but its luminance on screen fluctuates depending on the pattern size and the APL. Let's say you put up a 10% window and you measure it using any meter, and then you put up a 20% window, the readings will be drastically different. It is drastic enough for me not to be confident with whatever calibration I do. Because let's say if I actually adjust the backlight to about 120 nits using a 10% window, once I switch to an APL pattern, let's say an 18% APL pattern, the readings may actually go up or go down. I've never seen such a drastic shift in brightness or luminance depending on the pattern size and the APL, and this is very, very difficult in terms of the calibration. That means that whatever you calibrate, the final result that you achieve is only applicable at that particular APL. And as you can probably imagine, throughout the entire film, there could be different APL ranging from dark scenes to bright scene. So that is the first problem. The second problem is that by pulling up the adjustment menu to calibrate the TV, the presence of the menu itself actually affects the white balance on screen. So whatever pattern, let's say if I decided to go for a 10% window pattern, I put up a pattern on screen, I pull up the menu to try and adjust the grayscale, to try and adjust the RGB balance to achieve a neutral D65 gray. Pulling up the menu itself will change the reading on screen because first of all, the menu itself affects the APL or average picture level, and secondly, maybe there's some other things going on in terms of the dimming. Even if I switch off local dimming, the same things apply, which means that any calibration or any adjustments that I do has to be done by making the adjustment and then going out of the menu completely, take the reading, and then going back into the menu again with a few clicks of your remote to make another adjustment. And it's like pulling teeth. It's incredibly difficult. So the Samsung QLEDs also suffer from the same problem to a certain extent, in that the presence of the user menu will affect the on-screen luminance and colors, but at least they have provided a direct display control function in conjunction with Spectracal's Kalman software, where I can actually use my laptop with the appropriate pattern generator, the appropriate cable, and the appropriate software. I can use my laptop to make adjustments on the television itself. I'm talking about the Samsung QLED, by the way, on the television itself without actually pulling out any menu on screen. Unfortunately, this Hisense NU9700 don't have such facility. They haven't actually worked with Spectracal or Portrait Display, who is the parent company, the developer behind Kalman, to incorporate this function. So that may be something that they can actually do in the future to make this process, this calibration process, easier. So for SDR colors, I can't achieve accurate colors. If you look at the color checker chart that I've put up here, there are massive errors, massive visible errors, and nothing I did could actually reduce the errors to below the visible perceptible threshold of 3. So there will always be visible error. If it's not in one scene, it will be in the next scene, because the luminance and colors just change depending on the APL. So from that point of view, color accuracy is certainly a problem on this television, and unfortunately I haven't actually found out any way to dial it out. Let's talk about motion. If you remember my previous video review of the Hisense N6800, that was using a 60 Hz panel, so that had some issues with telecinic judder, some issues with lack of effective motion interpolation. But fortunately, this NU9700 uses a true 120 Hz panel, so you can get a smooth 24 frames per second playback, but only if you select the correct ultra smooth motion setting of 24p film or with the appropriate settings in the custom submenu. So you can get smooth 24 frames per second playback, but if you set the ultra smooth motion to off, then it will start displaying the telecinic 3:2 pull down judder. Right, and in terms of motion resolution, yes, you can get 1080 lines of motion resolution through the ultra smooth motion interpolation system. There is no backlight scanning or back frame insertion on this set. And when we watch some football, the colors didn't really look very natural to us. But in terms of the motion clarity, we're reasonably happy with the rendition once you optimize the ultra smooth motion custom settings. If you use the other stock settings, which is not off, then you risk introducing interpolation artifacts like shimmering around the players or the ball breaking up as it travels through the crowd. So that is the motion point of view. And the screen itself is okay in terms of uniformity. It is not the best in that I can see some dirty screen effect, but it is not the worst either. So I think if you are thinking about buying the screen for football, just be realistic in your expectations. So we've covered contrast, we've covered colors, and we've covered motion. Let's talk about video processing. So the video processing on this TV ranges from average to good, and the upscaling is certainly not as good as the top tier brands such as LG, Panasonic, Samsung, and especially Sony. If you put up an SMPTE RP133 test pattern, which is in 576i or PAL, then you can see that the characters and the lines are slightly softer than a 2017 mid to high end LG OLED or Panasonic OLED or Samsung QLED or the Sony Bravia televisions. But in terms of video mode deinterlacing and film mode deinterlacing, the NU9700 performs quite well with good jaggy suppression and good film cadence detection. Okay, let's move on and talk about HDR, which is a big thing these days. And when you're spending this much money on a television, you want good HDR. Oh, I forgot to tell you about the price of this television. So it's a 70-inch set and it will retail at £3,000, which is not an insignificant amount of money, but I'll talk about the competition at the same price bracket later on when I conclude this video. So let's talk about HDR. And given that this set has Ultra HD Premium certification, you would expect a good HDR experience out of this television. But the reality is not quite that. So to attain the Ultra HD Premium certification, you will need to have sufficient peak brightness and also DCI-P3 gamut coverage. Peak brightness on this television, once we put up the appropriate test pattern, a 10% window test pattern on screen, the peak brightness of this TV measured around 1200 nits, so it comfortably exceeded the 1000 nit criteria set by the UHDA. DCI-P3 coverage came in at around 94%, and it clearly has an Ultra HD resolution, and it does accept 10-bit video input signal. So from that point of view, getting the Ultra HD Premium certification is not a problem. So why do I say that the HDR experience is not as good as we could expect then? The main reason is again in colors, and there are no provision for color fidelity or color accuracy in the Ultra HD Premium certification. If you look at this color chart here that I have actually captured of this television, the Hisense NU9700, you can see that the tracking is all over the place. It's not linear at all. And this is a big problem because once I put up some HDR content, some Ultra HD Blu-ray to watch on this TV, I was really quite disappointed by the colors, especially when you compare it against another TV that can actually render accurate colors in HDR mode. So I watched all my usual 4K Blu-rays on this TV and I was never satisfied with the color rendition. Also, there are some problems with the PQ tracking. So if I actually set the contrast value of this television in the HDR mode to not blow out any highlight detail, for some strange reason, when I watch this snow scene in The Revenant, the minor detail and gradation in the eyes is not as refined as 2017 OLED, even though this Hisense NU9700 is capable of 1200 nits of peak brightness, and the 2017 OLED at most is capable of 800 nits. But because the PQ tracking is more accurate on the OLED, despite its lower peak brightness, and the PQ tracking on the NU9700 is all over the place. So you get a really compressed highlight at the top end, which causes the tracks in the snow, the individual ice crystal, to be less defined and more mushed up than the presentation of the 2017 OLED. And this is very, very disappointing because one of the key reasons why you have a higher peak brightness is so that viewers can actually discern the different steps in terms of the specular highlight detail. But I'm certainly not getting that from this television. And also there are some problems in terms of the noise and gradation management on this television. If I put up this scene from The Martian, this is the 4K Blu-ray by the way, the Hisense NU9700 exhibited more random noise and pixelation in many parts of the picture, causing the whole picture to look less refined, less pristine, look more dirty in the outcome. So here's the thing, these are things that are never actually accounted for in the Ultra HD Premium certification. To get the Ultra HD Premium certification, you only need 1000 nits of peak brightness, 0.05 nits of black level for an LED LCD, at least 90% of DCI-P3 color gamut, and Ultra HD resolution, native Ultra HD resolution, and 10-bit video signal acceptance. And color fidelity is not accounted for. Haloing or blooming artifact is not accounted for. The compression management and the noise and posterization is not actually accounted for. So those are actually fairly important attributes of picture quality as well, especially for watching HDR content. And unfortunately, I have to say that despite the Ultra HD Premium certification that this television has received, it doesn't actually deliver a satisfying HDR experience, at least in my opinion. So that is the HDR side of things. Let's go and talk about gaming. Input lag on this TV is fairly good. So if you set it to the PC/game mode, either in SDR or HDR, either in 2K or 4K, the input lag measured around 37 milliseconds according to our Leo Bodnar tester. But once we started playing some Horizon Zero Dawn, again, is that colors. The colors just doesn't look natural at all. And Horizon Zero Dawn has a lot of cinematic cutscenes that is meant to look quite realistic, and it just looks fake and cartoonish on this television, and there's nothing I can do to actually rectify it, which is a real shame, because given the appropriate colors, that game can look really stunning. Of course, if you are not used to accurate colors, you may think that this is acceptable, but the thing with high-end television these days is that most of them have either sufficiently accurate color out of the box, or they provide enough calibration controls for DIY enthusiasts or a professional calibrator to go in and do a job to get the colors more accurate, to be closer to the industry standard. And this TV, I failed. I just have to be honest about it. I failed miserably to try and extract accurate colors from this television. So what is the takeaway then from what I've said so far? I think the first thing is that it just goes to show that Ultra HD Premium certification is not the be-all and end-all of good HDR experience. It's not even a guarantee of a good HDR experience. As I've explained before, you can get all the specifications correct. You can get the peak brightness correct, you can get the DCI-P3 color gamut coverage correct, you can get the resolution and the bit depth correct. But if you have poor color accuracy, and I think part of the reason is because Hisense has put a quantum dot filter on this TV, and the quantum dot gamut is inherently very wide, and it's difficult for Hisense or any other company, in fact, who uses quantum dot to try and tame the colors to the correct standard. So the first takeaway is that UHD Premium certification is not a guarantee of a good HDR experience. And the second thing is that, and I hope that Hisense and Hisense engineers don't take this the wrong way, but I think that they have some way to go to match the video processing and the color quality of high-end sets made by top-tier manufacturers like LG, Panasonic, Samsung, and Sony. Now, here's the thing. I want to tell you a story about a manufacturer many years ago. So there's this manufacturer from South Korea that made lots of television, and back in 2007 the picture quality was fairly mediocre. So they have this proprietary technology called DNIE, but the end result was so bad that eventually users and video enthusiasts, even among reviewers, we joked that DNIE actually stands for destroy natural images entirely. But the company took these criticisms on board and started hiring a few world-class, knowledgeable consultants to teach them about video fidelity, color accuracy, to teach them about image processing. And they have improved by leaps and bounds. And eventually the company became the #1 TV manufacturer in the world today. And in case you haven't guessed, this company is actually Samsung. And I think Hisense is probably at that stage now where they are making very, very good value television, but clearly they are actually trying to go premium. By premium, I mean £3,000 is not actually a small sum of money. £3,000 actually to many people is actually a big amount of money to spend on a television. Now, obviously, this £3,000 will buy you a 70-inch set, which is probably the cheapest 70-inch set on the market in the UK today. I need to check other models. I'm not that clued up about 70-inch models. But the same £3,000 can actually buy you a 2017 LG OLED, the basic 65-inch B7 and 65-inch C7, although it's 5 inches less. They deliver a picture quality that is as nice as day can be. It is leaps and bounds above the Hisense NU9700 despite a lower peak brightness. And gamma linearity, PQ EOTF tracking, color accuracy, video processing, these are all important components. It's not enough to just actually put good specifications on a television and hope for the best. You can get the best panel, you can put, let's say, 500-600 dimming zones on this TV, and it still wouldn't matter, because if you don't have the correct video knowledge, the correct color knowledge to implement the correct video processing and color processing on these televisions, then you're not going to get a very, very good picture. And I hope Hisense don't take this as a criticism. I hope they take this constructively. But my hope is that they will start trying to find out ways to learn more about what an accurate image entails. And here's the thing, Hisense is a company that has immense marketing power. They are sponsoring Red Bull in the Formula 1. They are sponsoring the Russia 2018 World Cup. So marketing budget is not a problem for them. But here's the thing. I think you should probably spend some of the budget on R&D, on actually making better products. Because if you make a better product, then all your other marketing efforts will be amplified. If you don't make good products, then whatever marketing you do, eventually you'll be found out. Especially at an age now these days where there are various consumer forums talking about televisions. Some of these consumers are fairly knowledgeable, and there are sites out there like rthings.com who buy their own sets to review and does not need to actually depend on manufacturers to send them sets. So my key message to Hisense is this. I think you need to build a better product, and you probably need guidance from an external source, because you can continue plowing along like this, keep making the same iterative process to try and improve your product year after year after year. But how long is that going to take? By trial and error. You need someone to come in and give you guidance to try and tell you straight away what is wrong with your television and how best to actually improve it. Another issue when you're trying to go premium is that you need to provide value for money. You need to actually get your users to appreciate that they are getting value for money. And the one thing about the Hisense NU9700 is that the remote is very plasticky and it produces quite an annoying click every time you press a button, and then it just rattles away, and it's not a premium or luxury remote that you associate with a high-end television. So I can understand Hisense desire to try and go premium, to try and charge more for their high-end televisions to compete at the same level as the top-tier brands, but you need to build better products. That's my point. You need to provide value for money. So that is the two takeaway from me, that Ultra HD Premium is not a guarantee of HDR quality. And secondly, that I think for £3,000, £3,000, I would take a 65-inch 2017 LG OLED any other day. And if you want, to spend slightly more, $3,600, you can get the 75-inch Sony XE90, which will have more accurate colors. It has less zones, less peak brightness, but I guarantee you that will produce a better picture than this Hisense NU9700. So that is my opinion on this Hisense NU9700. If you found this video useful, please click the like button and subscribe to the HDTV Test YouTube channel for more videos like this. Thank you for watching, and I'll see you the next time.